Assalamualaikum and have a good day. I bid to examiner. I'm Asmira binti Abdullah and my supervisor is Dr. Azianti binti Saroni. Today, I will present a review on structural and optical properties of erbium doped borate glass. This is the outlines for today's video. This review focuses on comparing the structural and optical properties of borate glass doped with erbium ion. The findings of the review have a major effect on understanding the role of erbium in altering and enhance the structural and optical properties of the borate glass. Details on the comparison of structural properties of borate glass have been analyzed by XRD, FTIR, and UV-VIS spectroscopy. All the glass samples show no strong peaks in XRD analysis, confirming that they are all amorphous with no crystalline phase. Following that, FTIR analysis revealed that they are unique bands due to the vibrational linkage existing in the glass system. Erbium doped glass exhibit the clearest absorption detected in UV-VIS analysis. It is a non-toxic material that is safe to touch and regarded as one of the most essential materials to be used in daily life. Glass are transparent substance that is strong, resilient, stiff, and brittle. Glass also own the attribute of firmness and difficult to bend or be forced out of shape. Glass is classified as amorphous solid, which have a short range of derangement as compared to crystalline solid. Glass is different from crystal, which is no visible melting point, but it exhibits flexibility akin to crystalline solid. Glass is one of the most common kind of glass and may be found in almost any commercially made glass. Borate glass considered as unusual form glass due to a lack of crystal nucleation. Borate-based glass have been commonly used in many popular technical applications, such as photonic application, biomedical application, solar energy converters, laser solid, and radiation safety system. Borate glass is one of the most adaptable type of glass. Borate glass systems are widely recognized for their stable structure in the presence of ambient humidity, as well as their high corrosion resistance in mechanical strength and chemical toughness. Borate oxide glass are among the possible host glasses that are most suited for doping with rare earth ions. To create the glass, the matte quenching technique, chemical vapor deposition, and the sol gel are the method they are most widely used. But the matte quenching process is the first among the three techniques that are commonly used. Basic structure of borate glass. In 1932, Zachariasen and Ziegler were first discovered about moisture-less alkali or alkaline earth borate crystalline structure, calcium metaborate. The addition of a network former in borate glass system could result in conversion of triangular BO3 to BO form, tetrahedral structural unit. At the right of the video, there is the difference between non-bridging oxygen and the bridging oxygen, the trihedral and the tetrahedral. Rare earth elements have been intensively studied and gained a lot of intentions. The usage of the rare earth material as a dopant for glass series has grown significantly. Rare earth doped glass have been a popular study topic in the recent decades due to its potential uses in photonic optoelectronics and quantum electronics devices. The addition of the rare earth ions has a significant influence on the conductivity of the glass. Because of their excellent emission efficiency owing to the electronic transition, rare earth doped glass are considered unique kind of luminescence material. Erbium is a lanthanide element that is mostly utilized as an active dopant in optical system. Individual dopant and atom-like imperfection in materials are intriguing quantum technology platform. To date, erbium doping have been widely investigated among all optical active dopant, whether in silicon or other crystal, as it shows a coherent transition within the primary wavelength band of optical telecommunication. Rare earth element can behave as an effective sanitizer to improve up conversion emission from the NIR to the visible area. According to research, the addition of rare earth element seems an increment in refractive index and resulting in densely packed of rare earth modifier into the host material. The greater the number of dense packing network, the greater the value of the glass refractive index. Result and discussion. XRD pattern by Patwari and Araya. It shows that there are no sharp peaks instead of a broad peak. Barbie ETAL XRD pattern show no sharp peak that indicate that bismuth borate glasses are amorphous in nature. Borophosphate glasses containing erbium by Khan ETAL 2020 was spotted and pointed out the presence of road humps. Pattern reveal the amorphous nature of the glass. XRD pattern by Raji Guguk using matte quenching method show that the XRD pattern in different shape and broad diffraction peak. The white peak revealed that all samples are amorphous nature. The XRD pattern by Prabhu ETAL 2019, the result obtained did not indicate any sharp peak, as shown in the figure, that verify the amorphous nature of the glass. Lastly, by Chopra ETAL 2018, the figure show the XRD pattern have a large hump. Fourier transform infrared spectroscopy of erbium doped borate glass by Rajagogu ETL 2019. At 835, the bending vibration of the BO occur. At 1030, the BO bond stretching of tetrahedral BO4 units and the wave number between 1178 until 1185, the asymmetric stretching of the BO vibrations in triangular BO3 unit. By Zaini ETL 2021, between 500 until 750, the bending BOB links at 800 into 1200, the asymmetric vibration of the BO4 at 1200 until 1450, the asymmetric stretching relaxation BO band of trigonal BO3 at 1391 until 1407, the stretching vibration of NBO bonds of BO3 groups, and between 927 until 1205, the stretching vibration of BO bonds of BO4 groups. The study from Queen Wam ETAL 2020 at 693, the vibration at BOB linkage at 971, the stretching vibration of BO4 and NBO at 1259, the BO stretching of the BO3 and at 3750, the OH stretching vibration of OH groups. FTIR spectroscopy of erbium doped borate glass by Khan ETAL 2020. At 754, the symmetric vibration of PO in POP bonds. At 901, the metaphosphate unit overlapping with non-bridging oxygen of BO4. At 1009, the symmetric stretching of both OPO bonds and BO bonds of BO4. At 1212 until 1522, the vibration of a non-bridging PO2 and stretching vibration of BO3. And lastly, at 1995, the vibration of HOH bond. FTIR by Chopra ETL 2018. At 418, Zen O lattice disrupted at 640. Lastly, FTIR spectroscopy by Neon ETAL 2018 at 511. The BO and BIOB is a stretching vibration at 711. The BOB bending vibration at 982. The BO stretching vibration in BO4 tetrahedron at 1332. The BO stretching vibration of the BO3 triangles, and lastly at 3400, stretching vibration of OH. UV-VIS analysis of erbium doped borate glass. This is the UV-VIS pattern of sodium barium borate glass by Patwari and Araya 2018. The amount of rare earth ion in sample is 1.0 mole %. Second, UV-VIS by Zaini ETAL. They are using borate glass with 2.5 amount of rare earth. UV-VIS by Razali ETAL show that the clear transition is from 4H11 per 12 to 4S3 per 2. The amount of rare earth ion in sample is 1.0. They are using borosilicate glass. UV-VIS from Ushrani and Iraya, the clear transition is from 4I15 per 2 to 4H11 per 2, using the amount of rare earth 0.3 mole %, and using a glass of lithium lead borate. The clear transition from 2H11 per 12 to 4F9 per 2 from the Raja Guggu ETL 2019. Amount of rare earth ions in the sample is 4.0 using sodium lithium borate. 11 series of various borate glass emphasized on the dope with erbium ion was successfully reviewed. The addition of erbium ion into multiple series of borate glass show almost similar trend of result in XRD, FTIR, and UV-VIS. This result can motivate the researchers to study more on the doped borate glass, as the production of the glass are quick and inexpensive. Besides, the unique properties of the borate glass, such as low melting point, high refractive index, and stable dielectric values are observed. XRD analysis, it is proof that all the glass samples show no sharp peaks, indicating that the glass structure are amorphous in nature with no crystalline phase. Following that, the FTIR analysis that are distinct bank due to the vibrational linkage present in the glass system. The linkage of BO in BO3 are 697 to 1600 nanometer, where the links of BO in BO4 are 800 to 1200 nanometer. The bending of vibration of different borate rings occur in the 600 to 800 nanometer region. Finally, in the UV-VIS analysis, erbium doped glass has its own clearest absorption seen during the experiment. All the glasses can be used in the glass dielectric material. The finest glass characteristic may have broad bend range. There are two suggestions for this review paper, which is the optical properties and electrical conductivity. For the optical properties, by calculating the optical absorption and energy gap. For the electrical conductivity, to determine the impact of rare earth ion addition in the glass system on electrical conductivity and activation energy. The DC conductivity of the glasses measured using two-point probe technique.